welcome to everybody to our digital twin session. Again, you can find the full schedule back in the reception tab for what's coming next, so always go there to check in. And for this great session, I'm going to hand things over to Richard Soley, CEO of Object Management Group, and we can take it away.
Good afternoon, good morning, good whatever time you happen to be connecting in. No longer matters what time anymore. I'm Richard Soley. I'm Chairman and CEO of the Object Management Group. And for this panel, more relevantly, Executive Director of the Digital Twin Consortium. We have an eminent panel today to talk about digital twins. I'm not going to introduce my eminent panelists and let them introduce themselves and talk about themselves a little bit. The Digital Twin Consortium, unlike OMG, which is 31 years old, which is amazing. It was created before I was created somehow, magically. The Digital Twin Consortium is 10 weeks old. It has over 130 members today and is doing a bunch of things. In the next couple of weeks, we're going to publish a shared definition of those 130 members of what is a digital twin and what is not a digital twin. And also a library of use cases, which we've been collecting diligently for 10 weeks, and start to put together for open source to push to standards organizations like OMG, like IEEE, like ISO, for digital twins, so that not only do you get interoperability across the lifecycle of a digital twin, from as designed to as built to as maintained, but also interoperability between digital twins across different vertical markets. We've started with 4 vertical markets. Those 4 vertical markets are infrastructure, meaning property management, real estate, construction, and so forth. Defense and aerospace, manufacturing, and natural resources, meaning mining and oil and gas. But we're probably going to add some more as the time goes on. We thought 4 was about right for the number of members we expected and the bandwidth we expected in the first few weeks. But we have many more members than we expected, and we will probably be able to do better. Perhaps if the 3 of you could introduce yourself, Rob.
Hey, Rob Tiffany. So I'm a VP at Ericsson. I'm the head of our IoT data strategy there. If you don't know Ericsson, we make all that fun 5G stuff that everybody's talking about these days. Not the bad part, the good part. Bad. Spent most of my career at Microsoft. Probably the last thing I did there related to kind of what we're doing now is kind of as we incubated and brought Azure IoT to life. I really dove into digital twins back in 2016. I joined Hitachi and I designed their industrial IoT platform called Lumada. And so my viewpoint on digital twins is, especially when related to IoT, I started calling our platform more of a runtime for digital twins than anything else. And so, long history of digital twins in manufacturing and things like that. And so that kind of fit well. And then on the side, you notice I have this, what are the odds I have this picture behind me? I'm actually traveling. I'm on the road taking a big risk, hoping that the Wi-Fi works. I'm actually in Moab, Utah right now. And I did go see that thing, Mesa Arch, this morning at sunrise. So that was pretty cool. So hopefully this all works out.
We can only hope. That's a great picture behind you. Thanks, Rob. Ed, can you introduce yourself?
Sure. Hi, my name's Ed Wood. I'm the president and CEO of Dispersive Networks. I've been with Dispersive for about 1.5 years. Spent most of my career at Accenture. I was a partner, part of our telecommunications business, working on digital transformation for service providers. At Dispersive, we developed and operate a very advanced cloud-native software-defined network for secure edge-to-cloud communications to IoT, mobility, branch, containers, really anything with connectivity and compute. So we're deployed with the U.S. military, intelligence community, financial services, and energy. So look forward to this discussion.
Thanks, Ed. And last but not least, Mike, maybe you can introduce yourself.
Sure. Mike Pantalino. I work for Rockwell Automation, and I help out with our business strategy and also our partner development in the digital space. And so spent a lot of time inside of Rockwell, a lot of time outside, but most of the time has been inside of Rockwell, working on things like some of our incubators that we've done internally, focused on analytics and IoT, and also look forward to the chat today.
Of course, we already had a chat. I think we should have recorded the chat we had 2 days ago. That was a good chat.
You're right.
But we're going to have one now anyway. And the first question is a good question for all of you. what is a digital twin and what is not a digital twin. Now, we have a definition of the Digital Twin Consortium, but I really shouldn't use it until it's been approved by the membership. But it obviously has to do with modeling and simulation. It's a digital model of whatever needs to be modeled of a physical thing, whether that's its dimensions or its abilities or whatever, and anything that needs to be simulated about it. Rob, what do you think?
Well, you just gave away the whole thing.
Thank you.
How deep do you want me to go? Do you want me to do the high level, or do you want me to just tell everybody what the Rob Tiffany definition is?
I think we want to do the high level. I'm looking at the chats over here on the right, and so far so good.
No, so the history of the digital twin. A lot of people refer to NASA. A lot of times when I'm trying to describe digital twins to people, I ask them, "Did you ever see the movie Apollo 13?" And you had Gary Sinise there in Houston trying to figure out how to save, Tom Hanks and everybody else up in the limb and everything. And part of what was happening in real life there was a combination of a digital twin of the spaceship and a physical twin there in Houston as they were trying to solve their problems and get back home. But that was kind of the first instance, back in the old days, you had to use the real thing, a duplicate of the actual ship in this case. A little more history to give you on digital twins, is there was a guy named Dr. See, I've got my cheat sheet here. We got to be informed. So this Dr. Michael Greaves, he introduced the idea of it's called a double ganger. I think it was the University of Michigan. But a lot of the digital twin stuff came out of the PLM space, right? Like when you think of PTC and companies like that. And so I guess, early 2000s, he kind of started forwarding that idea and using the digital twin to model not only things, but the life cycle of those things. As you mentioned, from design to building to at runtime, maintenance, things like that, and decommissioning, as it were.
It's interesting that you mentioned Apollo 13. When I talk about what a digital twin is, I always use that clip from Apollo 13 when they pour a bunch of stuff on the table and say they have to build I think it was a square filter out of a round filter, and all they have is this stuff on it's 10 seconds of Apollo 13, the movie, but it saved the lives of the astronauts. That's a physical twin.
Yeah.
These days, you would do it completely digitally. You do it in a computer somewhere.
Right.
Does that sound reasonable?
Somewhat reasonable. I love it. So many of these things need to be relatable to people, when you give them an example like that, and they totally get it.
Ed, what do you think?
Well, I mean, to me, I see digital twin as sort of almost like an end state where we start to really maximize the true potential and value of IoT, right? But to do that, you kind of have you need a lot of convergence, right? You need distributed compute, right? That's going to be at the edge, and and then the cloud, and how do you connect all those things, and the power on the device itself, to then be able to start to pull that data, either at a part level or as a whole. And so sort of, to me, it's more of an evolution of where we need to go as a technology, right?
Where we need to go, that's a good way to put it. That's part for the course for the rest of the panel. Mike, how about you?
Yeah, so at Rockwell, we tend to focus on the manufacturing or the industrial side of this discussion. And so we tend to think about it as, and again, this is from one of our earlier chats, it's a system or model of models. And when we think about it, we think about being able for our customers to be able to model how they're making their product, how they're modeling their process, and how they model their automation. And for us, we do some of that really well on parts like the product. We have partners like PTC that do a great job there. On the process, we do a bunch with some of our recent acquisitions, and then partners like ANSYS. And then when it comes to the automation, again, that's kind of where our space is for being able to model and twin that.
But there's quite a lot of uses of digital twins besides manufacturing, of course. Manufacturing is kind of sort of obvious, but there are quite a lot of uses. We've got people that are modeling companies, that are modeling human bodies, that are modeling healthcare organizations, that are modeling infrastructure. Like what really got us going was Lend-Lease, which wants to model property management from a point of view of a digital twin, so they can model it completely online before they build the actual physical building, because buildings are expensive. What do you think the killer app is going to be, Mike?
Well, again, so we actually, with our Arena software, actually do some of that modeling of things that aren't just industrial. So we do everything from call centers to flow and things like that. So we also think about things in that way. When it comes to the killer app, we do think of, again, our scope is a little bit tighter on manufacturing. We think about our customers' ability to do things similar to what you had said before they actually get to the big iron and building stuff and pouring concrete and things like that, where they can look at an entire facility and including pretty advanced models that have to come into, does this fit? Are we, as we're making the product, is the machine going to line up with the next machine, and are the conveyors right? Should we put intelligent conveyance in? So all those types of things that can happen before the customer ever gets to the point that they're actually doing stuff in the physical plant. The beauty of that for them is obviously the saving time and money when it comes to that design.
It reminds me of the great book, The 21st Century Airplane, about the Boeing 777, the first Boeing airplane that was actually built completely online rather than in cardboard or plywood before it was actually built, so they could see whether it would fit together. Does that sound reasonable to you, Rob?
It's completely reasonable. You know what? I'd love to, if I can, just take a few minutes, maybe just kind of walk through some of the components of a digital twin, just generically, just to instruct our audience, and especially before your consortium comes out with their view of what it is. I'm going to ram my view down everyone's throat first. Luckily, I had the luxury of designing this stuff a long time ago, and so I spent a lot of time around twins. When you think about IoT in general, you think about, like you're talking about, machines. I'm going to just use some props here. We'll just say this is my machine, and I'm sending my telemetry across the air, and then I've got my digital twin of that machine here, right? Before I can do anything meaningful, IoT started, and we're just sending bits across the wire, and it's rows and columns and databases and things like that, and doing different kinds of analytics. But what's helpful is as soon as you can have that digital instance of that real thing over here, every last aspect of it, it really helps people to see it, to wrap their mind around it, and also you need to make things easy for analytics to do something with it. It needs to know what's coming. So I have my trusty cheat sheet here, but I did write all this stuff. So I'm going to walk you through just some elements of a digital twin. The first is, when you hear the word modeling, and again, lots of people are going to have different names for these things, but at a high level, we like to create maybe a digital twin model, or you may think of it as an asset class or a type. Like, for instance, and I go back to thinking of all the IoT platforms I've seen where every individual thing, let's say it's a particular type of car, I have to keep setting properties and commands and all that for each one over and over again. What you want to do is first that high level thing, like an asset class, like maybe it's an asset class for a Volvo XC60, and then all my instances are going to inherit from that, and I'm only going to have to do it once. And so I'm going to create all those attributes, and so you'll have things like telemetry properties, where it's kind of one-for-one matching from maybe sensors that are coming from that car, or the engine, or oil pressure, all kinds of things like that. But you're always thinking like, I want to help my downstream analytics for people who need to work with that data. And so you're labeling, you're naming all those sensors. You're saying what kind of data type is it? Is it an integer? Is it a string? Is it a float? What's the unit of measure? Because you need context for all that information coming over. So you're providing that extra metadata as part of your twin of this car, for instance, so that your downstream analytics, whatever it may be, understands what's coming at it and doesn't have to figure it out on the fly. And yes, someone said object-oriented in the chat, and that's exactly right. You're creating a base class, right? And then you're inheriting from that base class. You have an instance. So there's properties that are one-for-one, but there's also this thing called virtual properties. So think about it like if you were ever a database person, you had calculated columns. Some things, there's not an actual match to that property, but you may use a combination of values coming from data from different sensors and maybe some reference data to calculate. Like, for instance, your car, there's no such thing as knowing what miles per hour is on your car. It's actually a calculated value from different things. And so that might be more of a virtual property. You might have just kind of static properties, like, hard-coded, the car is 20 feet long, things like that, values that maybe don't change very often or don't change at all. Let's see what else. Command properties. You need to send a command. It's not about just telemetry. I need to talk to actuators on my machine or whatever it happens to be. And so you need to define what those are. Again, data types, units of measure, and so it knows what to expect. If I have a motor that's going at 10,000 RPM, and then my telemetry is saying, wow, it's getting a little too hot, I'm in the red zone on my KPIs, I might want to send a command back to it that says, hey, slow it down to 7,500 RPM. And so the unit of measure is RPM, the data type is maybe temperature, things like that. You can have process properties. Like you've got, everybody knows a process. It's a bunch of steps. It may be linear, it may be branching, but if I'm if working on an assembly line with a bunch of industrial robots, they've got a process that they all follow. That all can be defined. The twins define those things. APIs connect those things. Also, there's this notion too, a lot of times I've seen people, and everybody gets to start fresh and do baby steps. And I know this is new for a lot of people. But a lot of times the idea of a twin or a data schema has been very simple in a lot of platforms I've seen. Sometimes you might need to recognize that a subsystem of a machine deserves to be a digital twin unto its own. It's so complex. I may have a digital twin of my car, but my engine is so complex, maybe it deserves its own digital twin. And so you have a parent-child relationship between the engine and the overall car. And the engine's got all its properties that maybe have map, and so you can have causal relationships between, the RPMs are too high, or the engine's too hot, or oil pressure, or whatever. And that has a causal bubbling up relationship to your car not working so well anymore, right? And then if you take that notion of parent-child subsystem within a machine to a larger level, you talk about systems of systems, right? Maybe that next group is, I've got a bunch of industrial robots, and they're all twins, and they got twin subsystems, but all of them together, that group, makes up an assembly line. But I don't want to just say this assembly line is called this group and it's a name. Maybe that assembly line deserves to be a twin unto itself with its own properties, and it's alive. And then a bunch of assembly lines all together make up a factory. And if you're using that kind of that digital twin notion where there's causal relationships between all the components, then you kind of see a living factory. And Richard, as you mentioned before, it could be other things. It could be a person. It could be a patient in a hospital. The person's a digital twin. The heart is so complex, it deserves its own digital twin, right? So lots of great uses for this stuff. And I find it's helpful for folks just to wrap their head around it, but it's more understandable to people when you define things as twins.
Except you just define something, one piece that's very difficult, and that is you've got to compose digital twins to make a bigger one. Landing gear and the wings and the avionics make of an airplane, for example. Are there other things to watch out for in building digital twins, Ed?
Yeah, I mean, from my perspective, and what we're trying to solve for is around decentralized connectivity issue, right? So you've got the full potential. To get the full potential of digital twin requires significant processing of distributed, structured, and unstructured data, predictive edge analytics, and in the cloud, which we've been hearing about a lot today. And this requires the use of a multitude of connection types, right? Ad hoc mesh networking, LoRa, LTE, 5G, LEO satellite constellations. In some instances, these connections need to be real time, and the assets may be mobile, right? So that requires multiple forms of connectivity. And so 5G will have a big impact in dense markets, but mixed access will be around for a long time, right? So how do you connect assets that are in remote locations, disadvantaged sites? How do you integrate those assets across diverse sites securely and reliably is critical, especially for some of the use cases that Rob was just talking about, where you got to bring different pieces together to get a better understanding of the big picture.
Helps. Now, the panel description says digital twin and AR, something like VX is what they called it. I can't remember what they called it. What is the relation between AR, VR, and digital twins? Mike, can you enlighten us?
Yeah, I think it's one of those things where the AR VR really tends to get a lot of the, I guess no pun intended, the eyeballs, because people see it. It's something they can interact with in a lot of cases, and so it actually is a good representation of of how people think about it. And it does it is what comes to mind when people start to think about different types of digital twins. The real interesting part is where AR and VR and kind of the different values that they can give in different parts of the life cycle. So not just in design, which we've been talking a lot about the design, but also kind of in the operations of the twin, right? So when you think about what AR VR adds to it, in the time of design, there's the ability to actually interact with the model. So the walkthroughs, a lot of stuff you've seen with HoloLenses and kind of the immersion that you can have in there comes out of that. We also see in operations or in the runtime where remote operations can now be possible when you have a model that you can interact with, that you can either move in an AR or in a VR space. And then on the maintenance side too. So when, we've all seen different flows from different vendors or different opportunities from different folks, where the person that has to go do maintenance can now pull up a digital twin to see what things do I need to go fix, where do I think the problem is. And so those different kind of operations, those workflows that happen in those different parts of the life cycles, some of which are definitely AR, VR enabled, I think are an interesting opportunity when it comes to this whole digital twin element.
Well, in other words, we're going to see a lot of AR and VR of the simulation, the simulation side of a digital twin before we see the physical thing itself.
Yeah, absolutely. And again, I think that's where, if you think about where some of the design work is, we see that all happening all the time now. So again, just like you had said before, the plane is being designed, all the cars are being designed, they're on the computer, they're doing a bunch of the stuff in CAD. And now those tools can have a mixed reality component, whether or not someone wants to go interact with it, or physically, the AR model where it's physically overlaid on the model, or virtually overlaid on the model, and you get to see how it interacts. And I think that's on the design side. So it's the before it's built, but then while it's existing, you've got the running it and maintaining it elements of AR VR that have ton of, again, for us, like connected worker and those types of things, where we can inform folks so much better than we could before, because there's new mediums and new models to do it in.
We're starting to get questions in the chat session, so I think I'll switch to audience questions now. There's one from Matthew Yarger asking, are there new technologies coming out that may help alleviate some of the issues towards progressing digital twins? It's a good question. Was there anything new besides what's coming out from the Digital Twin Consortium? Rob?
I was just going to say, Richard, shouldn't someone else ask you that question so you can talk a little bit about standards?
I'm being nice and trying to let my panel answer the question.
Well, you can. Why don't you talk a little bit about some of the standards, because this is an important part of this space.
Well, there aren't any standards yet. The consortium is 10 weeks old, so they're going to be open source and there's going to be standards. But I think what Matthew, knowing where he comes from, because I know Matthew personally, his interest is imputing blockchain into a digital twin. There are solutions that exist today, and I don't say this as a member of the board of IOTA Foundation. So I really should let somebody else answer.
It's to his question, and you're right, having standards is a good thing, because it's certainly a mess out there. Just like every other dawn of every other technology, whether it's the PC revolution or smartphones or whatever, you had tons of players, and then you have consolidation, and IoT and digital twins and things like that are exactly the same. I think you and I talked about before, Richard, about just like when we were doing Lumada and Hitachi, we called our twins the asset avatars. But we had our way of doing it. You know how it is. We're racing to market. You define what you think the digital twin should be, and if everybody's using your platform, you're okay, right? But if you're using other platforms, and so I remember spending time with our friends at SAP. They had just launched Leonardo as their IoT platform, and they had a digital twin technology. And guess what? We had a working group spending time figuring out how to interoperate between their twins and our twins, and that's a thing. And so as the market, as the space matures, it is certainly helpful to figure out how things can map to each other, because that's what we ended up doing is you're building mapping stuff.
Yeah, and I think one of the other advances in this space is everybody wants to interact and get the benefit of the digital twin. It's just a very limited set of folks and or tools that can make twins. And so if you think of kind of the AR, VR version of it, you used to have to be a Unity programmer to get something on a HoloLens. But now there's all these really interesting ways that you can take various 3D and CAD/CAM models and move those into that space and now interact with it. And so I think it's the creation of the models that you can interact with and get value out of. It's shortening that life cycle so that it's not just a few people that can make the model, but that more people can interact with the models because the creation is easier. I don't know, Ed, what's your thoughts on that?
Yeah, I love Cynthia. She just
she just introduced your company.
This is absolutely what I was about to say, because I think part of it is also just the natural progression of technology where, I mean, we need to have the compute to process all this data and the connectivity. So, just the growth of edge computing is critical. It's kind of like how we were joking about AI, 20 minutes ago before the meeting started. And we learned these algorithms in computer science classes 30 years ago. Well, the compute wasn't there to actually use those types of techniques, right? And I think the same thing is true with digital twin. We have to, we now have these tools and technologies that we can start to build some of these solutions.
Well, in fact, it's a similar problem for IoT, as David mentions here in the chat. It's a similar problem for IoT projects in general, that is securing large, complex systems. And in fact, the Industrial Internet Consortium published 2 years ago a way to think about security in large industrial IoT applications. And everyone interested in security should look at that. It was just updated. It was updated earlier this year, remotely.
Interesting thing about security in twins too is there are great uses you may think of. Like, so the twin has the current state of the real thing. You have all your twins that are of the same type. You have the fleet kind of state. You can see how everybody's doing. You have the historical state going on forever, where it's automated, or sometimes it's a person does maintenance on a machine, and that's entered in. And that whole thing is a digital thread of the life cycle of that thing from birth to death. But there's this notion of privacy between twins. I know this sounds weird, or maybe this is role-based access control or something. But there's this notion that I've got, let's say I have XYZ car, and I noticed a number of them that in their twins that the water pump is going out at 60,000 miles. And I'm seeing that over and over again across my fleet of twins of the same type. You could imagine that's your flag to say, well, gosh, let's share that information and do a recall. Or obviously there's something going on here. And we learned that because a bunch of twins are doing that. But I always have people pop up and say, well, wait, who gets to talk to which twin, or, that kind of thing. It's, we're going to invent new layers of security for everything, I'm sure.
Yeah.
But there's always the what you want to do, and then there's the privacy and security thing that you got to think about before you go too crazy there.
Well, yeah,
I think, Rob, that comes out when it becomes that operational side of the twin, right? When it's the design side, it tends to already be fairly private. It's
sure.
You're running it or maintaining it. When you want to interact with it, then you have to have secure communications to make sure that there's nothing else going on.
Although that's exactly the problem that I hope Ed is solving, is security for as designed and as built and as maintained are very different things. Unfortunately, across the life cycle, digital twin looks different from person to person and from vendor to vendor.
Well, one of the other challenges is, as you move more toward digital twins, especially with these more complex digital twins where you're focusing more on the process versus the individual parts, there'll be an exponential increase in sensors and devices, which increases your attack surface, right? Because now you got more endpoints that need to be secured. Security was always an afterthought in IoT until now it's a huge risk that everyone's trying to address. And so, we have to, and then the other element is now the data is much richer, right? Which becomes much more valuable potentially, for nation states and others that are interested in, because now you've got more defined understanding of the weaknesses of that thing that you've created a digital twin over. So we have to take those things into consideration as well.
A really interesting conversation is happening over in the chat. started by Leonard Lee. Gaming plus 3D design plus digital twin equals IoT, AR, and VR. Does that sound right?
Yeah, I mean, I think that's pretty close to the way that I had described some of the stuff that happened with Unity, because again, some of these technologies are coming from different parts of the technology sector, I guess, and being and the influence of these kind of big things like how AR and VR, 6-7 years ago were just a maybe kind of someday, to the fact that now there's a whole bunch of those in everybody's living room in which they game with it, and now it's moving into, and now it's in design, and it's in factories, and it's in all these other areas, right? So yeah.
I just saw David type in blockchain plus OO as digital thread. I just got triggered right there. Okay.
Were we triggered positively or negatively, Rob?
I don't know. Every time I hear blockchain, it's like a microaggression. I don't know. I'll leave that for another conversation. Hey, you know what? Also, the word complexity, everything. Complexity is killing or has prevented the IoT market from getting even close to any of its aspirations. We're nowhere near where we thought we were going to be. It's massively underperformed, and digital twins could be in the same boat. I always try to. I know it's a cliche, just trying to keep it simple, stupid. But the digital twin thing, I feel like it's a knob you can turn, like turning your volume up to 11 or not. You can. I've seen years ago. I've seen companies that were focused on digital twins where they didn't build anything else, but they did the modeling, and there's a lot of like the 3D CAD modeling or stuff you might see from Dassault systems. And it's super complex. I've seen a container ship with every individual, compartment and everything. And there's this notion that if you want to do digital twins, you need to make this outrageously cool thing. And while it seems great in a demo, it overwhelms. People get overwhelmed. Regular folks are just trying to do their jobs at whatever industry they happen to be in, and they don't have time to get nuts. And so when I think of digital twins, I always think that you can use just as much as you want. You don't have to go all the way to the insane 3D CAD model of everything else. It could be just some simple properties. It could, you could choose to get more complex. As long as it's giving you value, that's a good thing. And then if you need to add stuff, you can increase value. But I always want to convey to customers that it doesn't have to be crazy complex. If Forrest Gump needs to build it, right?
It's about driving the outcome, right? Like it's
right.
Your model only needs to be as complex. Your twin only needs to be as complex as what you're trying to get to as a result.
As your simulation.
Yeah.
I mean, I was asked just yesterday, is the dimensions of a motor that I have to put on my floor, is that a digital twin? And the answer is, if that's all you're going to simulate with that digital twin of the motor, yes, that's all like hair. Will it fit through the door? Will it fit in the space? Will it connect to my other equipment and so forth? That's unreasonable?
Yeah, keep it simple. Sounds reasonable. Absolutely.
Well, in the vein of keeping it simple, I have to ask in the 5 minutes we have left about AI. Everything is AI these days. Does it have anything to say about digital twins and AR, VR?
Yeah. So let me just start by saying, let's just say this is the digital twin of something, right?
I thought you were going to stop with the yeah.
Were you not paying attention earlier, Richard? He wasn't going to stop at yeah.
We're not going to stop at yeah. You had me at yeah. Once you have that digital twin of whatever it is, it's what you're looking at, right? You move physical to digital, and now whether it's streaming analytics, if it's ML, if it's your mixed reality goggles, you're all looking at that now, right? And so that's kind of where it starts, and that's just the simple, that's the simple value in it. AI is just marketing terms for some machine learning or maybe some computer vision and some other fun stuff. But you could, if we want to stick with AI, sometimes I like to think of as digital twin as kind of that intersection. And this is runtime. This is not design, but at runtime, it's kind of an intersection between IoT and AI. It's kind of where you get in the middle, and you need it before you can start applying whatever AI stuff you want to happen to do.
In fact, there's a machine learning application testbed at the Industrial Internet Consortium. I'm sorry, I keep talking about that instead of Digital Twin Consortium. But it's a huge building outside of Tokyo, run by Toshiba, and this testbed is run by Dell and Toshiba together, which generates half a terabyte of data a day. There's no chance that any human being is going to read the half a terabyte of data, as though it's read by a machine learning system. So that's my example of a great use of AI in digital twins.
Yeah,
go ahead.
We're working with. We've got a joint offering that we're building or integrating with Accenture, Microsoft, and a few others. That sort of a combination of ad hoc networking of sensors, edge AI technology at the edge, secure connectivity up to the cloud, and then processing, further processing higher level AI up in the cloud, and then visualization of that data. And we think there's just a lot of applicability. And to your point, taking all that unstructured data, identifying patterns, right, like methane gas, detection or wear and tear on parts as part of a supply chain process, which is a use case that we're particularly interested in. And we couldn't possibly do that. Once we have the definition, then it's applying AI to find those patterns, right, so that we know what to look for. And so we think there's a lot of applicability there.
Well, we've got, it looks like 2.5 minutes left. That's just enough time for each of you to give a final closing thoughts. Mike, I think you're first.
Sure. So I think I'll wrap up with just a little bit following on the AI piece. I do think that, the opportunity for digital twins to incorporate things that are looking at optimization and being able to model things on certain outputs, it makes those two bedfellows quite more familiar. That sounded awkward, but the ability for them to have a digital twin that is describing certain things and modeling certain things, and then to have ML be able to predict things and do those types of things, I think is an important element of how those tie together. I think the one thing that we didn't mention, Rob mentioned it a little bit, one of the things, it sounds a little bit like a salesy line, but the digital thread being the thing that are tying our digital twins together, something that is really important. It's companies focused on it. We focus a lot on that, doing it in a secure and with context. And so I think that's another important element. We probably just didn't give it enough time with our time here today. But Rob, your final comments?
Yeah, I think everybody should, we've talked about a lot of things. If you make cars, like the Tesla comes with a digital twin. If whatever machine you make, you should deliver, when I think of a digital twin, it's a digital replacement of the owner's manual that you would normally get with your car, right? And when to do all that stuff. And so I'm a firm believer that if you're an OEM making any kind of machine or anything, you should be delivering a digital twin with that to your customer. And then it helps model what's going on in that machine and then you're doing the IoT thing and it's logging and sending telemetry back. And then whether it's going back to the OEM cloud or whatever, or if you're doing the first receiver kind of thing and you've got your own IoT thing capturing it at the edge, at least you'll know what to expect and how to analyze it and maintain it better. And so I'm a big fan of digital twins delivered with everything we make these days.
And I just want to, before I give it over to Ed, just Cynthia's quote's actually really important to tie what Rob had just said, and that is these have to provide a value that someone will actually pay for, right? So the idea is that the twin, in Rob's case of delivering a twin with the machine, it's got to be so that we can predict maintenance better, or that we know the as built is looking similar to what was as designed, or where it differs. So I think that's really important. Twins for twin's sake don't necessarily help anybody, but twins that are delivering an outcome that's of value, that somebody values and will pay for, is really kind of the crux of it. So sorry, I didn't mean to interrupt. You were.
No, that's okay. That's exactly right. I think we're going to see twins delivered without the equipment first, just as people want to see whether they can integrate the equipment into what they currently have. But nobody does that today. Have you seen it, Ed?
Yeah. I'm sorry. Can you repeat that last question?
Have you seen anybody deliver a digital twin of a physical device without delivering the physical device?
No, I mean, that's an interesting point. I mean, everything is software now, so I mean, that's entirely possible. What I was going to say, just to reinforce the point that Mike made in terms of final thoughts, is that if you have a target state architecture, that first define that target state architecture in terms of all the piece parts that need to be integrated. And then if you can identify a use case you don't have to do all of it all at once. And that's why I'm fond of like the supply chain model and around spare parts specifically, because we can go focus on a specific part, getting value out of that specific part and modeling that, and then applying AI and these sort of things. Now we have a framework for adding additional parts, based on higher priority, right? And that sort of iterative approach towards adding value, I think, is key.
Thank you. That takes us to 3:36. I'm actually a minute over. Sarah seems to have disappeared. I don't know what I'm supposed to do at this point.
I think you're supposed to do your closing thoughts, Richard, and then I think we can sign off.
And we can just sign off. We'll see what happens. I want to thank all three of you for a great discussion. It was exactly the discussion that we had like 2 days ago. Not recorded. We should have recorded it then. But that's exactly what ZEDEDA, I think, wanted for this session. And it was a great job, and thank you for participating in the panel.
Yeah, thanks, guys.
Thanks.
Hey, having us.